need to inform me. Okay. So I hope I am audible right now and my screen is visible to all of you.
Yes, it is.
Okay, cool. So we'll start with problem A and we'll go up till problem D. So we're not covering any more problems other than D because I mean they're really very tough and I don't want to spend a lot of time right now. Okay, so this was the first problem. I mean, in the first problem, there was nothing. It was just said that there is a string that is given to you, and you need to find a substring such that in that substring, the number of A's are equal to the number of B's. Okay, so I hope the problem statement is clear. Let me just open OneNote here, and I'll explain it really very quickly. Okay, so what we have is we have a string and we need to find a substring such that the number of A's are equal to the number of B's. So, you know, there is just very simple observation that is there in this whole question. So let's say you are at any index and you have A here. So you have A, and at some point, if you have any B's in this whole string, you will transition from an A to a B, right? Or if you take it the other way around, if you start from B, then there will be a point where you will be switching from a B to an A if there are A's in this whole string, right? So does this make sense to all of you? This simple observation.
Yes.
Okay, cool. So the idea is basically this only, that you know you start from the very first index. You go to the string and you start at the very first index. Let's say this index is an A. So what you do is you start traversing towards the right, and as soon as you find a B, you just simply print. Let's say you find the B at the index I. So you simply print the indices I minus 1 and I. Okay. Why is that so? Because let me just show you on Sublime, because it will be a little easier to write here. So let's say you have the string as AAA. I mean, you start with AAA, and let me increase the font size. Just a minute. Okay, seems like this is not working. Okay. Okay, now I hope my screen is visible to all of you. Just confirming once again.
Yep.
Okay, cool. So let's say you have the string and you start on the very first character, and your very first character is A. Okay, so you keep going towards the right until you keep encountering A's. As soon as you encounter a B, you just print these two indices. Okay, similarly for the string, if you start and you find a B, you keep continuing, and as soon as you find an A, you just print this substring. Right, so this will be the answer. And if at the end you don't encounter any A's, let's say, and in the string if you don't encounter any B's, then this just simply means that there is no answer possible. Right, so is the question and the solution clear to all of you? There is not much in this problem. Okay, a yes or a no, maybe.
Yes, it's clear.
Okay, cool. So basically, I'll just quickly show you my code for this, although there is no need for it. I sort of just overkilled it during the contest. So what I did was, I mean, this was my approach, my way of approaching this problem. What I did was I assigned A equals to 1 and I assigned a B equals to minus 1. So this whole problem becomes, you know, a problem of finding a sub array such that the sum of that sub array equals to 0. Right, so have you guys seen this type of a problem wherein you need to find a subarray whose sum is equal to 0?
Yes.
No.
Yes.
Right, so if you convert it to that problem, you can do that as well, but it is sort of an overkill because in that case you require a map and you need to keep track of the prefix sum. So this was something that I did, but you can obviously convert it to a very minimal form by just approaching this problem with the first idea. What was the idea? We just start iterating from the left to the right. As soon as we encounter a character switch, we just print these two letters. We just print these two indices wherever we encounter a character switch. Okay, so this is what I had implemented. Basically, this is a very standard way of implementing the problem of finding a subarray whose sum is 0. So I'm not explaining this right now, but you can obviously approach this problem with the first idea. Okay, so moving on to problem B now. Right, so yeah, let me just explain this problem. I hope the problem A is clear to all of you. Can we move to problem B?
Yeah.
Cool. So in this problem, you have a chess tournament, and every player plays with every other player once. Okay, so let's say I have three players, 1 comma 2 comma 3. So what will be the games? One of the game will be 1 plays with 2, 2 plays with 3, and 3 plays with 1. Okay, and the important thing to note here is that 1 plays with 2 and 2 plays with 1 are both the same thing. Okay, in this game one of them wins, or just there is a draw. So in the game of 1 and 2, either 1 can win or 2 can win, or there can be a draw. Okay, so there is just one condition in this whole question. You've been given a string, and string of n letters. So we have n players here. Okay, and you have a string of n letters wherein every character is either a 1 or a 2. So what does a 1 signify? A 1 signifies that the player at this index. Okay, so let me just make a string here, 1 1 something like this, 1 1 1 2 2 1. Okay, so this I mean, if you have a 1 at the very first place, this just means that what does this mean? Yeah, so this just means that the very first player cannot lose any game. Okay, and if it is a 2, it just means that you have to win at least one game. Right, this is what we want, and we are given these games. How many games are there? Can somebody tell me first of all?
Everyone plays with everyone.
Sorry, I think there is a lot of noise at your end. Maybe
Yeah,
somebody
there
else can
could
speak up.
be
Yeah,
there could be
Possible in
50
this case
players.
1 to 2.
sorry. Let's just keep it with one person speaking at a time. Yeah, so can somebody just speak up again?
Possible in the case 1 to 2 1.
Not possible.
Yeah.
Oh, I am not asking whether it is possible or not. What I'm asking is how many games will be there if there are n players?
N minus 1.
How many games?
N minus 1.
Why would there be n minus 1 games?
C2.
NC2, right? Let me write it like this. So let me just tell you why there are NC2 games. First of all of you can be on mute right now. So every player plays with n minus 1 other players. So how many games are there? There are n into n minus 1 games. First of all, this is the thing. But now what did we say in the very first part of this question? We said that 1 playing with 2 is the same as 2 playing with 1. So this just means we have to divide it by 2 because every game is being counted twice here. Okay, so these are the number of games actually. Right, and how do we represent this whole state of games? We represent them with a matrix. So we have an n cross n matrix where I comma j signifies the result of game between I and j. So how does it signify this? I mean, how does it represent this whole game? It represents it in this way, that if the value at I comma j is a plus, this means I beats j. Similarly, if j I comma j is a minus, then it means j beats I, and if I comma j is an equal to, this means that there is a draw. Okay, and there is just one more condition. If we have I comma I, we are not having a game with the same player. Okay, the player I cannot play with himself. So in this case, you just print an x here. Okay, so is the problem statement clear to all of you now? Like, what exactly is the problem statement saying?
Clear.
Cool. So you need to represent, I mean, you need to design a whole scenario in which there is this condition being held. What is the condition? That for the given string, if the letter at that particular index is 1, that means this particular player cannot lose any game. Okay, and similarly, if there is a 2, then this just means that you have to win at least one game. Now let's just first of all consider the places where there is a 1. So can somebody tell me that if there is a 1 at this index, what does this mean? This means that we cannot lose any game, right? So if I am talking about the player I, can I say that I comma j for any j cannot be negative? Can I say this?
Yes.
Okay. So when we can say this, so can we say that I comma j for any j is either equal to or a plus?
Yes.
Cool. So the thing is that let's say I tell you that for any particular ij, you assign a plus here. So can this harm me in some way? Can this be, not beneficial for me in some way? Can somebody tell me this? If I put a plus at I comma j for this player I, can this be somehow not beneficial for me in the long run?
J अगर 1 होगा तो माइनस हो जाएगा.
Right. So if j is a 1, then clearly this is not valid. So if j is a 2, is this valid? I mean, we don't really care about if j is a 2, right? Because that is not actually harming us. But if j is a 1, this is not valid. Now let's say I decide I comma j is an equal to. Can somebody tell me, will this ever harm me in any way? If I put an equal to now.
No.
No. Why? Because there are only two possible cases. J can be a 1, which means that J does not lose a game. But we are not beating J. We are only having a draw between I and J. So satisfied. Similarly, if J is a 2, this means that J has to win at least one game. But we are not preventing that. J can obviously win a game later on, right? But what we know is that I can never lose a game. So this simply means that if we put an equal to here instead of a plus, we are better, right? So this is also satisfied. I mean, this is not harming. Let's call it like this. Not harming, and I is satisfied. Okay. So can we like make a case out of this? So case 1, if I has a 1, then I put for every j, I put an equal to at that. I put an equal to at I comma j and j comma I. Right? Is this making sense?
Yeah.
Okay, cool. Now let's talk about case 2. If I is a 2, what does this mean? This means that we have to win at least one of the games. But after covering the case 1, what can I say? Can I say that all the players which cannot lose a game are already out? Can I say this after case 1? Let me put this here. All the players which cannot lose a game are already out. We don't need to consider them now because we've already filled all of these places. Right? Is this clear to all of you, or is there any doubt in this?
It's clear.
Okay, cool. So if we have I equals to 2 and I tell you that there is only one player left. There is only one player left. So can I satisfy this? Can I if I have, let's say, 1 and 2 left, sorry, let's keep it like L and R are left. So can I say that L beats R? Sorry. Let's say only L is left. Only one player is left, right? So if L is only left, so can I satisfy this in some way? Can I beat some other player if there is no other player left only?
No.
Only
No.
if it's a 2, right?
Okay, so if there are only two players left, let's say L comma R. So what can we have? Now both of them want to beat at least one of them. Now what did we say? L and R can only play one game together. So either L beats R or R beats L. But only one of them can be true, right? Both of them cannot be true. right? So if we have only 2 players left, this also means that we cannot satisfy this. But now let's say I tell you that there are greater than 2 players left. Let's say we have 4 players left. So what can we do? We can do 1 beats 2, 2 beats 3, 3 beats 4, and 4 beats 1. Can we do this? And satisfying everything if there are 4 players left.
Yes.
Similarly, if 3 players are left, then we can do 1 beats 2, 2 beats 3, and 3 beats 1. I mean, there is not much to actually implement after you've considered all these cases here. Okay, and I mean that is it. And if there are 0 players left, there is just another case. If there are 0 players left, do I have to do anything or everything is satisfied here? If there are 0 players left after the case 1.
I think the condition is not satisfied as 2 must win at least a game.
No, but if there are 0 players left, what I'm saying is that there is no character at which 0 is present. So this just simply means that nobody actually wants to win a game. If there are all ones in the whole string, that is what 0 players left means here. So
It will be no.
it will be no. Why will it be no? If I only have ones in my whole string, then can't I just put an equal to sign everywhere? This will just draw every single game and everything will be satisfied. No player will be losing any game. 0 players left means that there is no player left who actually wants to win a game. Okay, we've already covered everything here. So let me just remove the upper part here. Okay, yeah, let's just remove this part and let's analyze these cases once again very quickly. Okay, so we have case 1 when the given character I is a 1. So what this means, for every j I can never put a minus. Why can't I put a minus? Because this player cannot lose a game. And why can't I put a plus? Because at the end it might happen that j also wants to win a game. Sorry, j never wants to lose a game, right? So our best case in case 1 is to just put an equal to sign everywhere. And after case 1, what we know, all the players which cannot lose a game, which only want to either draw a game or win a game, they're already out. They're already out of this whole scenario, right? And if in case 2 we are just considering the number of players which actually want to win at least one game. So if there are 0 players left who want to win at least one game, we don't need to do anything. And if there is just 1 player left, we cannot do it. Similarly, for 2 players, we cannot do anything. And for greater than 2 players, we can just form a cycle and be done with it. Yeah, so now if you have any doubts in the first 2 problems, just let me know.
I have one doubt. For the case 2, can we simplify this like this, that if the number of 2's is less than 3, then in that case the answer is only no.
Yeah, right. So yeah, you can put it like this. No, it is not true actually, right? Because for 0 players left, the answer is yes. For 0 players left, the answer is yes. For 1 player left, the answer is no. For 2 players left, the answer is no. And for greater than 2 players, the answer is yes.
If there is only combination of 1 and 2, then always for the answer to be yes, the number of 2 should be greater than or equal to 3. So in that case, if it is less than 3, then it should.
Yeah, I understand. If the number of remaining zeros, sorry, the number of remaining 2's, they have to be greater than equal to 3. But if there are no remaining 2's, then we're also done.
Okay.
Right, so let me just see the chat here. Okay.
How we will be putting them plus sign?
How will we be putting a plus sign? So let me show you my code for this. Okay, so I hope Codeforces is visible to all of you right now. So can somebody confirm this? If my code is visible to all of you.
Yes.
Yes, visible.
Okay, cool.
Yes, it's visible.
So right now we are considering the first case here. What did I do? I just checked if s of I equals to 1, then for every j which is not equal to I just assign an equal to sign there, which just means that there is a draw in between these players in between these players I and j. Right? Is this clear? The case 1?
Clear.
Yes.
Okay, cool. And in the case 2, it is simply that if the number of remaining 2's they are less than equal to 2 and they're not equal to 0, then the answer is no. Otherwise, what I do is I just form a cycle. How do I form a cycle? Let me just show you that. Let me show you on OneNote. So what I do is I just consider how many 2's are left. So let's say 1 2 is here, then the second one is here, then the third one is here, then the third one has to point to the first one. So what you can do is you can assign an edge like this. Assign an edge between I comma I plus 1 mod number of 2's. Right? Is this making sense? Like how is a cycle being formed like this?
Did not
Yes.
understand.
Okay, cool. So let me explain this very quickly. Let's say I tell you that there are 5 zeros that are available. Sorry, 5 2's that are available. So this is 1, 2, 3, 4, 5. So can you tell me where will one? I mean, which game will one win? One will win a game against 2, right?
Yeah.
Okay. So this is I here. This is I plus 1 mod 5. And I is basically 0 based indexed. Okay. So for this player has to be beaten. For second, this player has to be beaten. For third, this player has to be beaten. For fourth, this player has to be beaten. But when you come at 5, so what is your index? Your index will be 4. And what will be your next index? Your next index should be 0, right? Considering 0 based indexing. So you have 4, then you have 4 plus 1 modulo 5. Which will be what? Which will be 0. Right? Is this making sense
Okay,
now?
got it. Yeah.
Okay, cool. So this is exactly what I've done here. I've just assigned a positive value for I comma I plus 1 mod that value. And similarly, I've assigned a minus for I plus 1 mod value and I. Okay. And wherever I is equal to j, I am just printing an x here. And whatever values that are left after that, you can just assign them equal to, because we are already covering everything now. So we don't really care whether somebody wins a game or not now. So we can just assign them equal to later on. Right, so is this clear?
Can you explain why for less than equal to 2 there will be, I didn't get that part actually.
Yeah, sure. So let me tell you, let's say there are two players, 1 comma 2, and one also wants to win one game, 2 also wants to win one game. So can there be a scenario where both of these conditions are satisfied, that 1 beats 2 and 2 beats 1, provided that there is only one game between these two players? The person who had this doubt, I think he can speak up.
Yes.
Okay. Yeah. So for two players, you know that we cannot have a situation where both of them beat each other because there is only just one game. Similarly, when there is only one player left, you cannot beat yourself, right? Because you're not playing against yourself, you're playing against others. So for one, again, the case is not possible. Okay. So I hope this makes sense to all of you now. Let's move to the third problem. Yeah. So this was an interesting problem. So what do we have to do here? Let me just show you. So you have these. Acha, just give me a minute. Let me just mute. Hello.
Yes, audible.
Yes.
Okay, cool. So let me just explain this problem really very quickly. So you have these values being assigned to every number. So you have an array here, and you have values assigned to every number, every index. So let's say this is something like 5, this is 4, this is 3. Let's keep this one as 6 maybe. Then you have 1, let's keep this one as 2. So what happens is that you start traversing through this whole array from left to right. When you go from left to right for every index, you pick up. I mean, if there is a number remaining, I mean, if it is non-zero, you just subtract 1 from it. For example, if we start moving from left to right, we have 5 here, so we change it to 4. We change this 4 to 3, then 2, 5, 0, and 1. Now the thing is that when you come again, you will start with 4, you'll have 3, 2, 1, 4, but you will not touch this one because this is already 0. So what happens is that after 4, this becomes another 0. So if you look at it, how are these numbers changing? First of all, you changed first one, then you changed second one, third one, fourth one, fifth one, 1, 2, 3, 4, 5, 6, sixth one, then you change the first one again, second one, third one, fourth one, but did you change the fifth one now? Did you change your fifth index when it was already a 0?
No.
Right, but did we change our sixth index? Yes, we did. Similarly, when you come again, you'll be changing this one. You'll be changing 1, 2, 3, 4. You won't be changing 5 and 6. Then you will come back again to 1. Okay. So what they want to have in this question is that for any two adjacent values, they should not be same. What this means is that you should not have a round trip and come back to the same index again. Like if you look at this array, and if I tell you that this index is repeating, that if you have I, then you again have I. What does this mean? This means that you remove one element from here, then you go here, you don't remove any element. Then you go here, you don't remove any element, and when you come back to I, you remove one more element. Right? So you are basically having a round trip and you're coming back to I. So this is something that we want to avoid in this question. We don't want to have the same value repeating. Or in other words, we should not have two elements in the same sequence consecutively. Right, so is the question clear to all of you? Should I move to the solution?
Clear.
Okay, now just tell me this. If I have a value x, and if I have a value y here, and if I have a value z here, and if I tell you that y is greater than x, so can somebody tell me, will there ever be a condition where x is in the round trip, that you put in x and you put in x again? Let me put this here on Sublime. Let's say we have our array something like this, 5. Then you have, let's say, 3. And you have some other number x, let's say. So can you tell me, will you be putting 3 twice? Will you be putting 3 twice ever?
Oh.
Okay, right. Now, first of all, tell me what is a round trip. A round trip is basically you go right, then you start from beginning and come back. Now, when will there be a situation where the element repeats? The situation will be there when you don't have any element bigger than your current element towards the right, or you don't have any element bigger than your current element towards the left. Right? Because if you have a bigger element towards your let's say right or left, what will happen is this 5 will get exhausted later than 3. So this clearly means that we will never have this round trip. Right? Okay, can somebody confirm if this is clear?
Yes.
So, and similarly, if we remove this x and if we have a 5 here, again, this will be the same situation, right? We don't need to care about this 3. Or do we have to care about this 3?
We don't need to care about.
Exactly. So, with this, what I can say is claim we don't need to track any values except the maximum in the array, right? Because if you look at any value, if this is not the maximum, then there will be a bigger value than this value towards the right or towards the left. And we have already said that, if there is a value bigger than your current value towards the left or towards the right, we don't really care because our value will get exhausted later than these values. Right? So is this clear?
Clear.
Okay, now comes the tricky part. Now we need to track the maximum value. Now there is another case 1. There are greater than or equal to 2 maximums in the array. So what this essentially means is that we'll have something like this, m, comma m, and let's say another m, or let's say we don't really care about any more m's. We only have 2 m's right now. What is the m? M is the maximum value in the array. And so can somebody tell me, will there ever be that round trip condition here now?
Never.
Okay, why will there be why will never that situation occur? So it would always be something like this, right? Everything would be a 0. This would be a situation. Everything would be a 0 at the end, because we are not concerned about the other values. We're only concerned about the values that are not maximum. So at the end, this would be our certain situation, right? So what will happen is we'll start from left. We'll go to this 1. And what we'll do is we'll remove this 1 and we'll convert it to a 0. And now we know that this is not in the round trip condition because we have some value remaining here. So what this means is that we would have gone from the right. Okay, let me explain it here. On OneNote, it would make more sense. So if in the end we have something like this. So when I start traversing towards the left and I reach this one, can I say that this element would have been encountered before? I mean, just previously? Can I say that?
No.
No. Why? Because this element would have been a 2 in that case. So if you don't consider this element, or if you consider this element or this element, there would be at least one element which would be coming before this one, right? So what will happen is when you come here, you change it to a 0. Similarly for this one, you don't have any condition wherein you have this element occurring consecutively. So you change it to a 0 and you are done with this whole array, right? So for this case, what is the answer?
N factorial.
N factorial. Why? Because we can arrange them anyhow. Okay, I guess somebody was on unmute. Okay, no issues. Now let's come to the case. This is the last case, where case 2. There is only one maximum. Okay, can somebody tell me, can there be 0 maximums? Can there be 0 maximums in the array?
Never.
No.
No, because if this is a non-empty subarray, or sorry, non-empty array, there will be at least one value which will be either greater than everybody, or it would be at least at least equal to the maximum one, right? So now there is only one maximum available. So now tell me, let's say I have something like this. If I put my maximum here, and let's say I don't have any more maximums, and I have m minus 2 here, will this ever work?
Not.
No.
No. Why? Because at the end you will have a condition like this, 2 comma, this will be 0. So when you come back to this 2, you will change it to 1. This will remain a 0. And then you come again, and this is a round trip. Okay. And similarly, if this is greater than or equal to, so we are basically concerned about the second maximum. If the second maximum is greater than or equal to, sorry, less than or equal to m minus 2, can I say the answer is not possible?
Yes.
Right. So the thing is that if the second maximum is less than or equal to m minus 2, the answer is not possible. But now let's say our second maximum is greater. Second maximum is what is greater than m minus 2. So, and let me just put it like this. Second maximum is greater than m minus 2 and is less than m. Can I say this? Can my second maximum be equal to the maximum when there is only one maximum available in this whole array?
Yes.
It cannot be, right? I mean,
No.
the answer is no for this, because if we only have one maximum in this whole array, there can be a second maximum which can only be at max m minus 1. So what does this mean? Can we say second maximum equals to m minus 1?
Yeah.
Okay, now let's say I put my m minus 1 here. Will this ever work?
No.
Why will this never work? Because we'll have a situation something like this, 0, 1, and then we come back again, this will be remaining a 0, and we have a 0, and this will be a round trip again. So what we want is our second maximum should lie towards the right of the maximum. So we should have at least one m minus 1 available towards the right of our current maximum. Okay, we should have certain something like this, m minus 1, and we can have all the other elements however we like. We just need at least one pair to be something like this, right? So yeah, let me just explain this case. What exactly is it? Let's consider an example here. So if we have our array something like this, 5, 4, 4, 3. So is this configuration valid?
Valid.
Okay. What about this one? Is this condition valid?
Yes.
Yes.
What about this one?
No.
Not valid.
This is not valid, right? So what is that one particular configuration which is not valid? The configuration is we have all m minus 1, and then we have an m, and we have something like this. This configuration is never valid. Okay, every other configuration is valid because we will be having one m minus 1 towards the right of m. Right? Is this making sense?
Yes.
Okay, so now tell me the number of ways this configuration will occur. So let me just give you a number here. M is available how many times? One time. M minus 1 is, let's say, available k times. And there are n elements. So in how many ways can this configuration occur?
N minus 1 ck into, like, we can arrange them in n minus 1
Okay,
places.
let's put it like this. First of all, we have to choose k plus 1 places, right? In order to put these k plus 1 elements, we have to choose k plus 1 elements. So we can do Cn comma k plus 1. Now tell me what elements can I arrange? Can I arrange my m minus 1s amongst themselves? I can arrange my m minus 1s, right? But I cannot change the position of my m. So the position of m is fixed, which is just one position when I have chosen these k plus 1 positions. But in how many ways can I arrange my m minus 1s if there are k m minus 1s available?
K factorial.
K factorial, right? So these are the number of ways not possible. And what are the total number of ways? Can somebody tell me the total number of ways?
N factorial.
N
N
factorial.
factorial. Right. So what are the valid ways? Equals to total minus invalid. Right. So what is this n factorial? Minus this value. Right.
एक बार n k plus 1 वाला केस बताइए ना.
Cn k plus 1.
Yes.
Okay. So what you can see here is that there are k m minus 1s available, and there is just one m available. Why? Because we are considering the case where there is only one m available. Right. So how many elements are there available total if you just include m and m minus 1?
K plus 1 elements.
K plus 1 elements. So what are you doing? You are just choosing k plus 1 places out of n places, right? So we just choose these places first of all. We fix these elements. Then for m there is just one way, and for the m minus 1s available there are k factorial ways. Okay, there is just one thing that I've missed. There is also this thing There is also this thing that you need to do. So you also need to take the factorial of this. Why? Because there are other elements as well, right? The other elements can be arranged however you like. So this is something that I was not multiplying during the contest as well. So this was something that I was also missing during the contest, and I missed it right now as well. So you also need to multiply it with n minus k plus 1 factorial. Why? Because these are the elements that are remaining and can be arranged however you like. Right, so let me put this here. Okay, so now is this question overall clear to all of you? Let me remove the unnecessary part here. Um, let's remove this. So these are the cases basically, and we can remove all of this. So this is your overall answer here. For case 1, if there are greater than 2 maximums, you just have n factorial. If there is just one maximum, you have this here as your answer.
Can you repeat how derive that formula?
Okay, sure. This formula you're talking about?
No, the valid one.
Valid. Valid is equals to total minus invalid.
This n factorial minus n c k plus 1.
Yeah, so I mean, what exactly did you not understand? Did you not understand this statement? Which statement are you not understanding?
I understood that when we are getting the valid pairs, sorry, valid permutations, but I don't know how have you calculated the number of permutations?
How have I calculated the total number of permutations?
Yes.
Total number of permutations, there is a very simple formula, n factorial.
I mean the good factorial. Total number of good factorials.
Okay, so you want us to find the total number of good permutations, right? This is what you want.
Yes.
So this is exactly what I'm saying in the valid ways. Valid ways is the total number of valid permutations. Valid permutations means good permutations.
Okay.
Okay. Okay, just a minute. Maybe this question was written in a different way. Maybe they had some terminology, but I mean, I hope this is clear to all of you. If you've read the question, this should be clear to all of you, like whatever I'm explaining here.
Yeah, clear.
Okay, cool. So
Just one question. Why are we doing like NCK plus one and not NCK?
NC k plus 1 because we need this configuration. We need to fix all these m minus 1s, and we also need to fix this m. This m cannot come here, okay? If this m comes here, it is a valid way. Right? This m has to stay towards the right of all the m minus 1s for this to be an invalid way. Okay, so what we are doing is finding the number of invalid ways. What are the invalid ways? Ways in which all the m minus 1s come towards the left of m. Okay, this is the number of invalid ways. So that is why we are fixing these k plus 1 values. We are choosing places for these k plus 1 values. In how many ways? Nc k plus 1. Then we are fixing this m, which has to be fixed on the rightmost place that we chose, which is just one way. And then we are, defining the number of ways in which m minus 1s can be arranged, which is k factorial. And then there are these values which are left over, which are n minus k plus 1. So you can arrange them however you like in the given places. So which is n minus k plus 1 factorial. Okay, is this clear now?
Yes.
Yes.
Okay, cool. So
This is only for one case, right? We have to add the other cases with this as well.
Which cases are you talking about specifically?
Like when we have multiple maximums and when the second maximum is m minus 2 or less. This factorial thing, this is just one case.
Right, but we've already covered all these cases, right? Okay, let's keep it like this. Can you tell me if there are greater than 2 maximums available in this array, how many ways are there to find valid configurations? If there are greater than 2 maximums available, greater than or equal to.
Right, yeah, it depends on the input only. Yeah, sorry.
Right, so this is n factorial and there is just one case available which we are covering here. Okay, yeah, so I think this was a little difficult to explain. But yeah, if you're still not able to understand, you would be able to understand from the recording. So let me just see if I'm recording. Yeah, cool. Okay, moving on to problem D, and let's see how many people are still left. Okay, looks like not many. Yeah, so just confirming once again before we start this question, my screen is visible to all of you and I am audible, right?
Yes.
Yes.
Okay, cool. Yeah, so this was a nice problem. Let me explain it here on OneNote. Okay, yeah. So this is your grid, okay, and these are the streets that are given to you. So how are these streets given to you? First of all, this is this whole perimeter that is going around this whole border, which is itself a street. What this means is that if you're standing here, you can go anywhere here, here, here. You can traverse this basically. Okay, and then there are some additional streets which are going either horizontally or vertically. So if you talk about horizontal streets, these can be something like these. And these horizontal streets are complete. What this means is that you can't have a horizontal street going like this and ending here. If it starts at the left border, it has to end at the right border. Okay. Similarly, for the vertical streets, if they start at the lower border, they have to end at the upper border only. They cannot end in between. Right. And what do I say? After all these streets, there are certain points that are given to you. And there is one property of these points. The property is that all these points will lie on at least one of the streets. Okay, so is this clear? Is this whole scenario clear to all of you? If you haven't read the problem, like if you look at this example, these black lines are the streets, and these blue dots are basically the points. And no point can be in between. Like it cannot be at any random place. It has to be at a place where there is a line going. So these points can be at a place where there is just one line going, and these points can be at a place where there is just where there are just two lines going, where there are two lines going. So can somebody tell me, can there be a point where there are three lines going from that point?
Never.
No.
Why? Because all these lines are just vertical or horizontal. If you consider the intersection of vertical and horizontal lines, you cannot have more than two vertical and horizontal lines intersecting at the same point. Okay, I mean, you can look at any point and this will make sense to all of you. Yeah, so what you want to do in this question is that you need to find pair of points such that, let's say you consider this point, let's say you consider this point, and let's say you consider this point. So you want to find pair of points such that if you take the shortest path along these streets, your overall distance is greater than your Manhattan distance. So can somebody tell me what is the Manhattan distance?
The summation of mod of the x coordinates, the difference of x coordinates and difference of y coordinates.
Okay, that is like a very theoretical thing, but can somebody tell me in a more like visual way? Like if I want to calculate the Manhattan distance between point A and point B, how would I actually traverse?
Go to an intersection and then go to A.
Right. This is something that you can do. This is the intersection. If you draw these lines, you can go to this intersection, then you can go to B. Otherwise, you can also do this. Okay. Nobody's stopping you from doing this as well. Let me show you. Yeah, you can do this. Nobody is stopping you from doing this, but mind you, the distance here will remain the same. Why? Because this is like you are traversing this much towards the right, and you are traversing this much towards the upper direction. This will remain same however you do it. Okay, you can go like this. This will remain the same. Right, so this is basically the Manhattan distance. You just find out, like the first person said, you just find out the difference between the x coordinates and the difference between the y coordinates, and you take their absolute value and you add them. Okay, so this is the Manhattan distance, but now what we want to find is we want to find the number of pairs for which if you go along these streets, you cannot take any random direction, you have to go along these streets. So let me take up this example. So if you have this point and you have this point, so tell me what will be the shortest path from going from A to B?
No path.
No path. No, these are also streets. Okay, let me just highlight the streets here. So these are the streets.
Up, right, down.
Yeah, just a minute. Yeah, you can go up, then you can come here, then you can come here. Okay, but is this distance greater than your Manhattan distance, or is this smaller, or is this equal to your Manhattan distance? Tell me this.
Greater.
Greater, right? So I'll just give you a quick observation. When is your Manhattan distance ever greater than your, when is your current distance greater than your Manhattan distance? So your Manhattan distance is what? You just keep moving towards the right until you want to traverse towards the right. And then you keep traversing towards the downside, right? But if I ever have to go up and then come down again, my distance will get added, right? Or if I just have to go sometime left and then come back, my distance will get added, right? So this is the thing, and you can consider it like this, that if you have this whole grid, and if you consider 2 points, now let's consider when will this point, when will this pair of points be not a valid point? And by a valid point, I mean that the distance which is minimum if you go along the streets, it is equal to the Manhattan distance. Okay, so yeah, let's consider the conditions when this will be the case, when the Manhattan distance will be smaller than your current distance. So let's say I tell you that both of these points have horizontal lines passing through them, and there is no vertical line here. There is no vertical line in between them. So can you reach from point A to B in Manhattan distance?
No.
Why? Because see, you have to traverse towards the, sorry. Okay. Yeah. You have to traverse towards the right. Okay. That we can do, we can go here. But we don't have any way to climb up. So in order to climb up, we have to use certain other vertical lines. And where are these vertical lines? These are either towards the right of B or towards the left of A. And what did I first tell you? I told you that if you want to go through your Manhattan distance, and if you want to traverse towards right and up, you can never go down or left, right? But in this case, we'll have to go left, or we'll just go right extra, and then we'll have to come left sometime, right? So is this condition clear to all of you? That if you just have two horizontal lines and there is no vertical line in between, this will be not a valid point. This will not be a valid pair. Can just somebody confirm once if this is clear?
Yes.
Yeah, clear.
Okay. Similarly,
Clear.
can you visualize this in the sense of vertical lines? If there are vertical lines and there is no horizontal line in between, there will be, greater distance compared to your Manhattan distance. Just visualize it like I've told you in terms of horizontal lines. Visualize it in terms of vertical lines. Like just rotate this whole figure. Right, that would be the same situation. So what is our claim here? What is our observation? 2 points.
चला गया क्या?
एक second. Am I audible to all of you?
Yeah.
Yes.
Okay, cool. Okay, so this is our observation if we have 2 points on different lines. First of all, tell me if 2 points are on the same lines. Can we go through the Manhattan distance? 2 points on the same lines.
Yes.
Okay, so let's just write it here so that we don't miss out on cases. 2 points on same line, don't need to consider. Okay, and for the second case, we have 2 points on different lines. Now we have two cases. We have vertical lines with no horizontal line in between, or we have a horizontal line, horizontal lines with no vertical line in between. So if we have any of these two cases, can I say that my pair of points will not be a valid point? Like I will have to include it in my number of points with Manhattan distance being less than the current distance. Can I say this?
Yes.
Okay, cool. So what we'll do is we'll just remove this first case right now. Let's not talk about these being on different lines. Let's just consider it randomly. Okay, and I'll show you with an example here. So can you see 3 and 4 here? 3 and 4 are on different vertical lines. Let's just skip the concept of vertical lines right now. Let's just consider that they are present on vertical lines. They can be on the same lines as well. Now you see that there are no horizontal lines passing between 3 and 4. Like, is this clear to all of you? Like, are you able to visualize this, that there is no horizontal line between 3 and 4?
Yes.
So we are having to take a path which is not optimal. So this is one pair of points which is invalid. Similarly for 3 and 5, you can see that there is no horizontal line which is passing through them. So we have to take a bigger route. You can consider another example like what else can you consider? Okay, how about how about 1 and 7? Can you consider 1 and 7? These are on horizontal lines with no vertical lines in between. So this will also be an invalid pair, right? Okay. So now tell me, if I have a point from which both vertical and horizontal lines are passing through, can this point be ever contributing to an invalid pair? If we have both horizontal and vertical lines going through this. No, why? Because you can consider any case. Like if you have any point, this point has to have a vertical line or a horizontal line, right? If you have a horizontal line, this will intersect here. If you have a vertical line, this will intersect here. So what this means is we can just ignore the points which have both vertical and horizontal lines passing through them. Right, so what we'll do is now we'll just consider the points for which there is only vertical. Let's say we consider the points for which only horizontal lines are passing through them. Okay, yeah, let's consider it like this. So now tell me the number of pairs which are invalid. Is pair 1 and 2 invalid?
Yes.
Okay, let me just shorten it a little. Yeah. So pair 1 and 2 are invalid, right? Why? Because there is no vertical line passing through them and they are on different horizontal lines. Now tell me, are 2 and 3 what do I say? Are 2 and 3 invalid or not?
Not invalid.
Not invalid.
What about 4 and 5?
Valid.
And what about 1 and 5?
Valid.
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 What about 1 and 4?
Valid.
Right. So this is essentially what we are doing here. We are just segregating these points in terms of lines. So when we are considering points on horizontal lines, we'll be considering the vertical lines in between. Okay. So how will I find my answer here? If I have to find my answer, can I say that in every segment? Yeah. So can I say that in every segment I can just take C and 2 and this will be the number of ways? In every segment. By a segment, I just mean the number of points between two vertical lines. Can I say this?
Yes.
We can say this, but there is just one loophole here in this whole problem. This was something that I hadn't observed in the very initial stage of the question where I was reading it and forming certain observations. But this is also very important. This pair is valid, 1 and 2. So how do we remove this? I mean, we'll be writing a general algorithm, right? We cannot be writing an order of n square algorithm checking everything. we'll be writing a general algorithm, something like order of n or order of n log n. So we'll have to keep track of this, right? How will we keep track that 1 and 2 are not counted? Tell me this. We can
subtract.
yeah, exactly. What we can do is we can count every pair which is invalid, and then at the end we can subtract these valid pairs. How will we subtract these valid pairs? We'll just go along every line, and we'll do the same algorithm that we were doing, but this time we'll be subtracting instead of adding. Okay, so let me just show you this clearly. Initially what we'll do is we'll consider all the horizontal lines to be same. We'll not differentiate between them anyhow, and we'll keep taking points. So if you consider this segment of points, let's say how many points are there? 1, 2, 3, 4, 5, 6, 7, 8. So how many ways are there if we take a normal case, if we are not subtracting those points as well?
8C2.
C82, right? 8C2. And now we need to subtract certain points. What will be the points that we'll be subtracting? This 2C1, again 2C1, and let's keep 3 here, then 3C1. This will be 9C2 then. 3C2, sorry. Okay, just a minute. I've taken it a little wrong. This should be 2C2. Okay, sorry. Okay, is this clear to all of you? Like, the general algorithm should be clear to all of you. Then what we can do is, right now we are doing it for vertical points on horizontal lines, and we are considering vertical lines as similarly for the points on the vertical lines and horizontal lines acting as barriers or acting as streets here. Okay, is this clear?
Yes.
Okay, cool. So what I'll do is maybe I'll just leave the implementation on you. I can show you my implementation. It is a little hard to implement, but you'll have to figure it out on your own. I mean, I won't explain the implementation here, okay? Because if I just explain the implementation as well, then the overall problem is just, I mean, it's just sort of useless for you now. So I can just quickly show you how a little bit I'm implementing it. So what I've taken is I've taken these points, and then I have vertical lines, then I have horizontal lines. And what I'll do is, obviously I'll have to keep everything sorted, right? Okay, let me give you a very small hint here. When you will be doing this certain thing of keeping track of points and horizontal lines, what exactly will be the technique that you will be using? Can somebody tell me this? How will you iterate? How will you iterate so that the overall complexity is linear and you don't go into a quadratic case? Like if I have to traverse in two arrays, let's consider it like this. If I have two arrays and I have to traverse in them, so I'll keep one pointer here I, and I'll keep one pointer j here, right? And that is how we will be iterating, right? So what will be the technique? The technique will be two pointer. Okay, so I'm just giving you a very small hint here. Think about two pointers while implementing it, and you will be able to implement it. Okay. So yeah, I think I won't explain the implementation further here. This hint should be enough, I guess. If you have any issues implementing it, you can always look at my submission and try to implement it on your own. But if I tell you the whole implementation of this problem, then the problem is just of no use after that. Okay, so can we end this whole thing now? Is everything clear to all of you?
Yeah, thank you.
Okay, cool. And I mean, do try out this last problem. It is a very cool problem. If you start implementing it, you will, I mean, maybe learn certain new techniques as well, because it is not just about two pointers. There is certain binary search involved as well here. Okay. So I would highly recommend that you try it on your own and don't just leave it. Okay, then see you all. Bye bye. Thanks for attending.